Okay, we'll see the section formula in this session and a few more topics. So let's say A has coordinates x1, y1, B has coordinates x2, y2. Okay, so I'll think of a point P. I don't know its coordinates, but all I know is the ratio in which P divides the join of A and B. That is AP is to PB. This ratio I know. Let's say the ratio is M parts is to N parts. It's like if AB is 8 centimeters and P is somewhere here, let's say AB will be 2 centimeters and PB will be 6 centimeters. So AP is to PB is 2 is to 6, which is 1 is to 3. So I know the ratio in which P divides AB. Then the coordinates of P are given by P of x comma y is it's cross multiplied. Okay, so it is M times x2 plus N times x1 by M plus N comma again M y2 plus N times y1 by M plus N, mx2 plus nx1. So we will get the coordinates of point P. Sometimes the coordinates are given and you will have to find the ratio, or you have to find the other point and so on. Also, you need to remember, sometimes they will say find the ratio in which the x-axis divides the line joining these 2 points. See, if it's x-axis, any point on the x-axis is the form x comma 0. Okay, so you'll be equating the ordinate in that case to 0. It is y-axis. It will be 0 comma y, any point on the y-axis. And if, let's say I have 2 points A and B, x1, y1, B is x2, y2. Suppose P happens to be the midpoint, special case, right? Then the coordinates of P are x1 plus x2 by 2, comma y1 plus y2 by 2. Okay, this you need to remember. And where will this be helpful? See, in okay, suppose I give you a triangle with 3 vertices, A, x1, y1, B, x2, y2, and this is C, x3, y3. Let the centroid, see, one kind of question can be like, see, from A, I will draw a line onto BC, to the midpoint of BC, I'm going to draw. So D is the midpoint. From A, I'm going to, from the opposite vertex A, I'm going to draw a line. AD becomes the median. So D will be the what? Midpoint of BC. Okay. So then I can find out the length of AD, distance formula, right? AD. So all this is possible. So you need to be careful. Now, what is the centroid? Now, this triangle has three medians, 3 vertices, and 3 sides, and so therefore 3 medians will be there. The 3 of them meet at a point, right? That's called centroid. Suppose they give you the 3 vertices of a triangle and ask you to find the centroid. The centroid is nothing but x1 plus x2 plus x3 by 3, comma, y1 plus y2 plus y3 by 3. This is quite straightforward. Just you substitute the values and get it. One more application of midpoint is where suppose you have any parallelogram, rhombus, rectangle, square, they are all parallelograms, isn't it? So remember, in a parallelogram, diagonals bisect each other. So the midpoint of diagonal BD will be the same as the midpoint of diagonal AC. So maybe 3 vertices will be given of the parallelogram. You will have to find the 4th vertex and so on. So just remember these things. That is for a application of section formula, midpoint formula. And next we'll go on to the equation of a line. So there is something called slope of a line, right? So what is slope? It is nothing but, first of all, what is inclination? An angle, line makes an angle theta with the positive direction of x-axis in the anti-clockwise direction. Then, see, this will be 150. This will be, let's say, 30. So theta is 30 degrees. This is the, and you take the angle that it makes with the positive direction, the anti-clockwise direction of x-axis. So tan of this angle is nothing but the slope. Tan 30, that becomes the slope here. Okay, it's also called as the gradient, but very commonly used terminology is slope. So slope of a line. This slope has a lot of significance. Suppose two lines are parallel, their slopes will be equal. Suppose slope is denoted by letter M. So M1 is the slope of line 1, M2 is the slope of line 2. If they are parallel, their slopes are equal. If the two lines are perpendicular, that is if they are going to meet at 90 degrees, then the product of their slopes will be -1. That we need to remember. And equation of a line. So first of all, when 2 points are given, let's say x1, y1 and x2, y2, you can find the slope of this line, y2 minus y1 by x2 minus x1. Yeah. So if you know the slope, and if you know 2 points now, we can even 1 point is sufficient, right? But of course, to know the slope, to find the slope, we use both the points. So then we can find the equation as y is equal to m into x minus x1. Okay. Y into y minus y1 is equal to m into x minus x1, or y minus y2 is equal to m into x minus x2. Now that we know m. Suppose for a line they have given the m and 1 point, then we can use directly y minus y1 is m into x minus x1. So if 2 points are given, we can first find the slope and then apply this. If the slope and point are given, very well, we can directly use it. The another thing is that sometimes they'll give you the y-intercept, that is the from the origin where the line meets the y-axis, you see that portion of that segment is called as the y-intercept. It is C, right? This coordinates are 0, C. So if you know C and if you know the slope, then the straightforward formula is y is equal to mx plus c. So slope point form this is called, or slope intercept form this is called. C is the value of the y-intercept. M is the slope. Y is equal to mx plus c. So we can find out, that is, if 2 points are given, we can find the slope. From the slope, we can find the equation. One slope and 1 point is the slope is provided also, we can find. Then when the intercept is given also, we can find out the equation of the line. So also remember again, parallel lines, slopes are positive. Slopes will be equal, and if perpendicular lines, the product of the slopes will be -1. Okay. Also, if the line is making an acute angle, the slope will be positive, because tan of an acute angle will be positive. Yeah, that means it is theta is acute. Theta is acute. Suppose tan theta is negative, that means slope is negative. That means theta is obtuse. It will be like this. It will be inclined like this. It is making an obtuse angle with the x-axis. So slope also will give us that information. And also remember, slope of x-axis is 0, and slope of any line parallel to x-axis is 0. Slope of y-axis is not defined, or any because tan 90 we get, right? Because y-axis is making angle of 90 degrees with the x-axis. So, or any line parallel to y-axis, its slope is not defined. This information you should know. Then coming to circles, you need to remember these few things. That is, you have a perpendicular from the center to the chord. It's going to bisect the chord. Okay. Suppose AB is the chord, O is the center, OC is the perpendicular, AC will be equal to CB, and OC will be perpendicular. As in, AC will be equal to CB, OC will be perpendicular to the chord. That is a perpendicular from the center to the chord. It will bisect the chord. Then the other things that you need to know is the arcs are proportional to the angles on which they stand. Larger the arc, larger is the angle that it subtends to the center. And then if you have 2 points A and B, you join them to the center, you get a point 2. The same 2 points A and B, you join them to any other point on the boundary, let's say C. So the boundary angle will be half of the central angle. So if the boundary angle is 30, this angle will be 60 degrees. So remember, the boundary angle is half of the central angle, or the central angle is twice of the boundary angle. And it goes without saying that angles in the same segment are equal. This also you need to remember. So see, A and B are joined to a boundary point C. The same A and B are joined to a boundary point D. So if this is 30 degrees, even this angle that I'm drawing here will be 30 degrees. From this logic, the next consequence is angle in a semicircle is 90 degrees. So if A and B represents the diameter, the ends of a diameter, then this will be 90 degrees. Angle in a semicircle is 90 degrees. Then, yes, you need to remember that you can have a line which cuts the circle at 2 points, which is a secant, which just touches the circle at 1 point, which is a tangent. Now, if you're going to consider the point which is going to just, a line is going to just touch the circle at 1 point, that line is called as tangent. And at the point of contact, radius and tangent are perpendicular. If OA is the radius, and let's say PA is the tangent, OA will be perpendicular to AP. Radius and tangent are perpendicular. And also, you have to remember that if O is the center, then if P is an external point, remember PA is equal to PB. Okay, from an external point, when you're drawing two tangents, OA is of course perpendicular to AP, OB is perpendicular to BP. So PA, the two tangents are equal in length. PA is equal to PB. Tangents from an external point are equal. And even this angle will be equal. You can see here, this angle will be equal to this angle. That is, this angle and this angle are equal. Okay. All right. And then properties of cyclic quadrilateral. Suppose you have a circle and then you have a quadrilateral where all the 4 vertices lie on the boundary of the circle. It becomes a cyclic quadrilateral. ABCD is a cyclic quadrilateral. One important property is the opposite angles are supplementary. They add up to 180. A plus C is 180. Likewise, angle B and angle D will add up to 180 degrees. Opposite angles of a cyclic quadrilateral are supplementary. This is about it. And coming to other properties, suppose you have a chord, let's say, and then you have a tangent. Okay, the chord and the tangent are making some angle, let's say theta. Now, this is, as you have put a tick mark, that is segment 1. The chord has divided the circle into 2 segments. Now, in the other segment, which doesn't contain theta, you take the ends of the chord and join it to the boundary point. You will get again an angle theta. That is, angle in the alternate segments are equal. You can directly use this property. So you can see what has happened. AB is a chord and there's a tangent. So the chord and the tangent are making an angle theta. The ends of the chord are now joined to some other point C on the boundary. And that angle ACB will be same as the angle between the chord and the tangent. That is, the property is angles in the alternate segment. Okay. Also, one more thing, wherever you have this perpendicular from center to the chord, it bisects the chord. Likewise, when you have 2 radii, remember it will be an isosceles triangle. You can use those properties also. while solving problems related to circles. Okay, so this is all about circles. You must remember alternate segment theorem. Radius and tangent perpendicular at the point of contact from an external point from an external point to a circle. We are drawing two tangents. They are the same length. Okay. Coming to similarity. Yeah, similarity is in layman's language, same shape at different sizes. So that means the ratio of the sides will be the same, will be equal, but the corresponding angles will be equal. Ratio of sides will be proportional. So you can have two triangles, ABC and DEF. So remember that when I say that ABC is similar to DEF, the corresponding angles will be equal and the corresponding sides are proportional. Sides about CPST. So you can establish similarity in different ways. One is two angles of one triangle are equal to two angles of the other triangle. AA is as good as AE. If I know two angles, I know the third angle. This is one criterion. In terms of sides, SSS, if three sides of one triangle are equal to three sides, not equal, proportional to three sides of the other triangle, the two triangles are similar by SSS. Then if two sides are proportional of one triangle to the other two sides of the other triangle and the included angle between them are equal. When it comes to angle, it is equality. Then it is SAS. So any one of the criteria can hold good for congruency. That is, once we establish congruency, then we can say the corresponding parts are, like if it's corresponding sides, they are proportional and its corresponding angles will be equal. When it comes to trigonometry, just remember the standard values in it. It's good to remember. Sine, cos, tan. Sine, cos, tan. Then if it is sine 0, 90, 30, 60, and of course 45. So it's good to know this, and the other things can derive from this. So we just have to know sine 0 is 0, cos 0 is 1. Then there's a right relationship. Sine 90 is 0. Sine 90 is 1 and cos 90 is 0. So tan 0 is 0, tan 90 is not defined. Sine 30 will be half. Cos 30 is root 3 by 2. Take the diagonal relationship. Cos 60 is half. Sine 60 is root 3 by 2. So that makes sense that tan 60 will be root 3 and tan 30 will be 1 by root 3. So 45, tan 45 is equal to, sine 45 is equal to cos 45 is 1 by root 2. Tan 45 is 1. So in heights and distances, whenever 45 is involved, remember, it will be an isosceles right angle triangle. So moving further with this, you will have, you can use the identities. That is, you know what is sine, right? Sine is opposite side upon hypotenuse or perpendicular upon hypotenuse. Cosine is adjacent side upon hypotenuse or base upon hypotenuse. And tan will be nothing but ratio of sine to cos or opposite side by adjacent side, or we can say perpendicular upon base. So then there are other relationships. 1 plus tan square is equal to theta is equal to secant square theta. Sine square theta plus cos square theta is equal to 1, and 1 plus cos square theta is equal to cosecant square theta. So it's good if you know all these things. And also we can say sine into cosecant theta. Sine theta into cosecant theta is equal to 1. Secant theta into cos theta is equal to 1. Tan theta into cot theta is equal to 1. These relationships will help us in solving identities. Yeah. This is about this, and it's also good to know the trigonometric ratios. Yeah, that is 1 is equal to sine square plus cos square. I can also write 1 as cosecant square minus cot square. I can write 1 as secant square minus tan square. Okay, then the Pythagorean triplet 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41, 11, 60, 61, 12, 35, 37, 16, 63, and 65, 20, 21, 29. So these are the triplets. And in heights and distances, remember one thing, angle of elevation is the observer is down. You're looking up, and it will be your theta. This is the observer here. The object is, let's say, A. So you're looking up. You can apply. Whenever hypotenuse is given, you will be using sine and cosine. And when the adjacent side and the opposite side is given, it's better to go with tan. You can have two triangles, right angles also in a problem. Remember one thing, like see in this problem itself. Okay, as we go closer to the object, the angle of elevation increases. So I'm here at point A. I move to point B. This is the apex C, and D is the base. So from point A, I move to point B. Remember, the angle of elevation will be increased. Same thing when it comes to angle of depression. Same logic. As you move further away, the angle of depression decreases. So that you need to remember. Angle of elevation and angle of depression.